Machine Learning for Absolute Beginners. Chapter 7. Linear Regression. Linear regression is often considered the hello world of supervised learning algorithms. It is a straightforward technique used to predict an unknown variable using known results. In this chapter, we'll explore the basics of linear regression, starting with simple linear regression and then moving on to multiple regression, which involves multiple independent variables. Simple linear regression. Simple linear regression uses a single independent variable to predict a dependent variable. To illustrate, let's use the Seinfeld TV sitcom as an example. We plot two variables, the season number as the x-coordinate and the number of viewers per season, in millions, as the y-coordinate. Plotting the data after plotting these variables on a scatter plot, we observe an upward trend in viewers starting from season 4 and peaking at season 9. In this case, the number of viewers per season is the dependent variable y, and the season number is the independent variable x. The regression line. By applying simple linear regression, we insert a straight line, known as the hyperplane, to describe the upward trend. In a two-dimensional space, the hyperplane serves as a flat trend line. The goal is to split the data such that the distance between the hyperplane and observed values is minimized. This distance is known as the residual or error, and a closer fit indicates more accurate predictions. Understanding the slope. An essential part of linear regression is the slope, which represents how much the dependent variable y changes for a unit change in the independent variable x. The slope helps make predictions, such as estimating the number of viewers for a hypothetical 10th season of Seinfeld. By inputting 10 as the x-coordinate, we find that the predicted number of viewers is approximately 40 million. Linear regression formula. The formula for linear regression is y equals bx plus a, so y is the dependent variable. X is the independent variable. A is the y-intercept, the value of y when x equals 0. And b is the slope, indicates the relationship between x and y. Calculation example. While programming languages handle these calculations automatically, understanding the process is beneficial. Using a sample dataset, we calculate sum of x, total sum of x values, sum of y, total sum of y values, sum of xy, total sum of products of x and y for each row, sum of x squared, total sum of squares of x values, and total number of rows. The slope b and y-intercept a are calculated using these sums, and we insert these values into the linear formula to predict outcomes. Multiple linear regression. Multiple linear regression extends simple linear regression by using more than one independent variable to predict the dependent variable. While more variables can account for more factors, they must be relevant and show some correlation with the dependent variable. In multiple linear regression, independent variables may be related to each other, leading to multicollinearity, where two variables cancel each other out, providing little unique information. To avoid multicollinearity, assess the relationship between independent variables using scatter plots, pair plots, or correlation scores. Ideally, independent variables should be correlated with the dependent variable, but not with each other. Summary. In summary, linear regression aims to establish a relationship between independent and dependent variables, with the goal of accurately predicting outcomes. Multiple linear regression is used when more than one independent variable influences the dependent variable, requiring careful selection to ensure relevance and minimize multicollinearity.